All right, so welcome everyone and good evening. Um, I think few more will join in. Meanwhile, we can, start. So all of you have attempted the assignment. Everyone, who all have attempted the assignment? Rubo, have you done it? Oro has done it. Kshitij has done it. Aditi, I did the PDF you had sent. Okay, great. All right, so good. So today, we are continuing with the units and dimensions chapter, and today we are going to complete this particular chapter. Okay, so after this chapter, we will start the mechanics part of the curriculum, which is the true physics. Right now, we are just learning how to measure things, what are the errors, what are the dimensions. Okay, so you cannot call it the real physics. This is just a basic prerequisite which all of you should be having. So do not judge entire physics by this particular chapter. So this is, I think, very theoretical chapter. At the same time, not very tricky questions are there, and you know, yeah. So the varieties are little lesser. Okay, but then at the same time, it gives you an opportunity to score also, because since it is part of curriculum, there is bound to be some numericals from this particular chapter also, and we have seen over the years at least one numerical is there in J advanced also. Okay, so they somehow they are liking this chapter, as in they know that students ignore this, so they just twist a question a bit, and a tricky question, I mean, not so tricky, but yeah, still little bit of trickiness can be there. They can include vernier caliper, screw gauge, and everything else, okay, that which you learn in the lab. All right, guys, so let us start the today's session. Today's session, we will be continuing with from wherever we have left earlier. Okay, so today we are primarily focused on the errors. Okay, prime focus is learning about the errors in the measurement. Whenever you measure something, there is bound to be error. So I think last class, did we discuss about the accuracy and precision? Can you type in? Okay, just a minute. I think some issue with the sharing of the screen. Okay, right. So we have discussed it. Okay. All right. So let us continue that discussion. Today we will start the discussion with topic called errors. Write down errors. Okay. So why we are learning errors. First, you need to understand that. Otherwise, every time I teach you something, you're like, okay, fine, why I'm learning this and that. So now I'll just give you an example. Okay, so I'll just give you an example, and you'll realize how important it is to understand the errors associated with the measurement. Okay, for example, you're building a multi-story apartment. Okay, so you need to design the beam of that, and you know that based on your calculation, whatever you have calculated and measured load, how much this and that, everything will take, you understood that one pillar can take a load of let's say 1000 kg. Okay, so you need to make sure that the apartment, just hypothetical case, should have capability to have 10,000 kgs. So you will have 10 pillars. Okay, so now the problem is, when you are calculating and measuring whether a pillar uh, can withstand 1000 kgs or not, you don't know exactly whether it is, whether it can withstand 1000 kg, or 10 kg is less than that, or 10 kg more than that, because you are not every time very precise about every measurement you're making. Okay, so even though you want, let's say, 10,000 kg support, you'll not have exactly 10 beams. Okay, because 1000 kg, which you have measured the amount of load one pillar can take, you are not confident about it. Okay, so now the question comes, then how confident are you whether it can take 1000 kg or not? Okay, now that confidence level depends on how you have measured everything else. How you have measured the mass, have you measured it properly, was there a random error there? Okay, so all that taken into account, suppose the error associated with the measurement is itself 100 kgs. Okay, so you don't know whether pillar can take 1000 minus 100 or 1000 plus 100. So what you will do, you'll design a pillar for 1100, so that even if it is less than 100, it is still 1000 only. Okay, so eliminating random error is not possible, that we have discussed the previous session. Okay, it is not at all possible, but knowing the maximum amount of random error is very important. Suppose I know whatever error is there, maximum error cannot be more than 100 kgs, so I will design 100 kg more than what is coming out of my calculation. Okay, so knowing error is an integral part of every measurement you do. Okay, so that is why we are that is the reason why we are systematically studying about the errors. Okay, now talking about the error, there can be two types of error. Fine, so all of you draw this kind of diagram. Write down systematic error, systematic error and random error. Okay, now there can be many systematic or random error. Can you, based on your experience, can you tell few examples of systematic error? By the way, do you know the meaning of systematic error? Anyone? What does it mean, systematic error? Anyone? No one? Same error done again and again. It's anticipated, known cause, correct. Okay. Systematic error is that kind of error which can be measured exactly how much is the error. Okay. So if you know exactly how much is the error, you can as well remove it, isn't it? You have measured that. I will every time, whenever I measure the mass of something, every time I measure 5 kg less. So if you know it is 5 kg less every time, whatever measurement you take, add plus 5 kg, your error will be gone. Okay, so those kind of errors are systematic error, and you can easily get rid of them. All right. So can you tell me the examples of systematic errors? Just give me a few examples. Whatever comes in your mind. Quickly. Reading length from 1 centimeter instead of 0 point on the scale, mistakes in one chapter, any situation or construction. Okay. All right. So basically, amount of reactant produced, a worn out measuring tape. Very good. So all of you are getting, all of you are able to tell proper, examples, and I'm happy about it, more so because these are your own example and you're not referring anything. So that is the best part, and this is how you should learn physics. Okay, you should not refer any book when I'm asking you to think independently. Anyways, so systematic error can be classified into 3 parts. Okay, write down. Now you'll understand all the example, which part of the systematic error these examples should belong to. Okay. Systematic error can be instrumental. You, of course, you have to use some instrument to measure anything. So it can be instrumental error. Fine. It can be environmental conditions, or you can say experimental conditions. Experimental conditions are not proper. Okay. Or there can be personal bias. Personal bias could be like, parallax error. Someone has a habit of looking things like that, some angle when he is not looking at the scale reading, he or she is not looking at the scale reading vertically down like that. They are always inclined your head like this. So because of that, parallax error will happen. Fine. And other personal error could be that every time you conduct experiment, you are angry. Okay. And if you are angry, you tend to make a lot of errors, which is because you are not in a normal state. So that is personal bias. Okay. Instrumental error, can you tell me a few example of instrumental error? One example, someone has given a worn out tape. That is a very good example. Others, what is the other instrumental error which happens every time and you try to remove it whenever you conduct an experiment? Correct. Zero error. Zero error is a very common instrumental error. Okay. Every other instrumental error can belong to worn out. Like a spring is not as flexible as it used to be. So there are many other things, but the most common instrumental error is zero error. Okay. Experimental conditions. What do you think? Give me one example. Experimental conditions. Okay. Have you ever been into let's say a jewelry shop you have been into, and have you ever seen how the person measures the weight of the gold? Have you seen that there is an enclosure inside which he keeps the gold? You have not been into that, right? So now why is that? Because gold is so expensive. You put a gold like that, and the wind will suppose blow from one side. The wind speed itself can change the mass. Let's say it changes just by 1 gram. 1 gram costs you around 4,000 rupees. So you don't want to make any error in the measurement of the mass. Now same thing you won't do when you're measuring the mass of a stone, because you're like, okay, fine, whatever error is there, I don't care, because it doesn't affect anything. So you want to be very accurate with the measurement of gold mass. So your experimental condition should be exact. Fine. So what we have learned, experimental condition can be changed and you can arrive at the more accurate readings. That is what the goldsmith does, right? So now, based on these examples, we have understood that these errors can be removed, right? These errors, write down, these errors can be removed. Have you ever bothered how you remove these errors? How can I remove these errors? Anyone? We do something in every experiment to remove these errors. What we do? Every lab record you make, do you write like this? Step number 1, remove zero error. Step number 2, this. Step number 3, that. So you have a step-by-step procedure. Okay. So if you follow the guidelines step by step, every step, without getting frustrated, you will be eliminating systematic errors. Systematic errors will be gone. Okay. Just blindly follow the procedures. Okay. So this is how systematic error works, and you can get rid of them very, very easily by following the through scissors. Now, the most notorious of all is the random error. Okay, by the nature of the error, these error occur randomly. Okay, they occur randomly. Fine. So they don't have any bias, they do not have any bias. They don't have any bias. So it is not that every time you get less than the actual reading. Sometime you get less than the actual reading. Sometime you get more than the actual reading. So you never know which side the error is and how much is the error. Even that also you're not sure. Sometime the error will be 1 kg. Sometime the error will be minus 0.5. Sometime the error will be 2 kg. Sometime minus 1.75. So, the random errors just fluctuate. Okay, so you'll never be able to identify what is that. But if you somehow know that this is the boundary in which random error will lie, your random error cannot be more than 2 kg, so it can be 2 kg less or 2 kg more. So that is what we are going to do later on. Okay, now tell me, by the way, they cannot be removed, right? They cannot be removed. They can't be removed. Give me examples. Examples of random error. Anyone? Examples could be, yeah, that you can say, not exactly, you're not measuring it actually. Fine. So the one example, I'm just throwing it, these examples, like power fluctuation. So some point, somebody's home, there might be some short circuit happened, and that has affected, 5 or 6 block away some house. Now, what kind of effect will be? It is totally random. Okay, so you can't predict it. All right. Second is sudden blow of wind. You can't predict from where the wind is coming from. And I'll give you one more interesting example is the wind from the fan. Okay, wind from the fan doesn't have any preferred direction. It can't go from, let's say, every time left to right or right to left. So it is totally random. Okay, so suppose you cannot conduct experiment without fan. That is what, you are so desperate that fan must be there. Okay, so that fan will create a random error. Okay, and the most common example, changing in reading because of changing temperature. Yes, that also you can say. The changes in temperature can be random also. Okay, the most common example which you can't do anything. Okay, power fluctuation, you can say, okay, I will use the direct current for the experiment. Okay, so you have changed the entire experiment itself, so the random error associated with the fluctuation can be gone. Okay, since sudden blow of wind, you can remove it, but error will be random if it blows. But this error you cannot get rid of. This error, even if you change the entire experiment, also will be there. I'm talking about least count error. Write down least count error. Anyone, have you heard of what is least count? What it is? Ever heard of least count? Oh, correct. Smallest unit. Write down the smallest unit an instrument can measure. This is the least count error. Okay, so every instrument that you deal with, anything you take, every instrument will have a smallest unit. Lesser than that it cannot measure. Okay, have you noticed that sometimes you use vernier calipers to measure the distance, right? Why you're using vernier caliper? Why not, let's say, proper scale it itself? What is the problem? Write down least count error as the heading. Why we are using vernier calipers? Lesser least count, how does it matter? Lesser least count means what? Okay, so now tell me over here, let's say I put a scale over there. This is a scale. Okay, this distance, the length of this is how much? Everyone, how much is length of that line? 2.2. Someone is saying 2.2. Okay, now tell me whether it is 2.2 or 2.215. Do you ever know? Will you ever know whether it is first or second? You'll not know. Okay, because you don't know the second and third decimal place. What are the digits? As the scale marking are having least count of 0.1 centimeters. Fine. So that's the reason why after first decimal place, you are not able to tell what is the reading. Okay. So that's the reason why there is a difference between 2.0 and 2.000. There's a difference. The difference is I'm sure these two digits are perfectly zero. Okay, this guy is only sure that this is 0. Sorry, this is 2. All right. Now this digit can become 1 also if the second digit is 9. Fine. So there is, least count error which you cannot get rid of. It actually depends on what instrument you are having. Now tell me how much maximum error this instrument can have. What is the maximum amount of error this instrument can give you? Everyone. 0.1 centimeter. All of you agree? 0.1 cent. Yeah, it is starting from 0.00 to 0.09. So that is 0.1, 10 places. 0, 1, 2, 3, like that, up to 9. So 0.1 centimeter is the maximum possible error. So max possible random error, write down max possible random error of any instrument is its least count. Okay, so maximum possible error in this case, when you're measuring in centimeter, is 0.1 centimeter. Okay, now you will never know whether the error is less than, 2.2 plus 0.1 or 2.2 minus 0.1. Okay, so you will say that my reading belongs in this range, 2.2 plus minus 0.1, and you are giving a very conservative estimate because you have to be 100% sure. You can say, no, my surety is it is more than 2.25. Okay, I'm not talking about here how much sure you are with respect to this. I have to take care of worst possible situation, right? So I will calculate the maximum possible error. So whenever I'm writing a reading, let's say 2.2 I've measured, along with it, I'll write its error also like this, plus minus zero point 0.1. So error can be maximum plus zero point 0.1 or minimum, it can be plus zero point 0.1 this side and minus zero point 0.1 that side. So your actual reading belongs between 2.1 and 2.3. Okay. So basically, we cannot remove the random error, right? This is very clear. We cannot remove the random error. Okay. So if we cannot remove the random error, what we do? We will manage it. We will manage it. It's like if somebody has disease, a chronic disease, for example, like diabetes. Okay, diabetes cannot be cured. So you manage it. You eat properly. You take care of the medications properly. So there are several diseases like that which cannot be cured. So you manage it. Okay. Similarly, these random errors cannot be removed. So you need to manage it. Okay. So how to manage the random error is what this topic is all about. Okay. Now, before even managing it, you must be measuring it first. Suppose someone has to manage the diabetes or the sugar level of his body, then he or she needs to first measure the sugar level, right? So that's the reason why the first topic is to quantify the error itself. Okay, so all of you write down. We are talking about. Oh, this thing is not gone. Huh. So we are talking about how we can quantify the errors. Fine. So there are three kinds of quantification done. First one is absolute error. How to quantify? Then relative error. How to quantify? And then percentage error. Okay. So these three things will be defined in this topic: absolute error, relative error, and percentage error. Now, whenever we talk about error in an experiment, you might be remembering that you always take multiple readings, right? You don't just take one reading and say that, okay, fine, I'm done. I suppose I ask you to experimentally find out the time period of pendulum. How many readings you take? I think you have done this experiment, finding the time period of pendulum. So typically what readings you take? How many? Around 10, 9 or 10, right? So those guys who are serious about their experiment will take around 10 reading. Those who don't care about it, they'll just take one reading and write down few readings less than that, few readings more than that, and tell the teacher, okay, fine, I'm done. So don't do that. Anyways, so we are talking about how we can calculate the absolute error. First of all, we'll do that. Now, I'm assuming you are taking multiple readings. Can you tell me a reason why you are taking multiple readings, right? Taking multiple readings is very important in every experiment. Taking multiple readings. Huh. Just give me 1 second. Yeah, tell me, why we take multiple readings, all of you? Okay, so the assumption is that you have followed all the steps of conducting experiment. If you have followed all the steps of conducting experiments, then what can be assumed here is a systematic error is gone. There is no systematic error. Fine. What remains is random error. Okay, random error can be sometime lesser than the actual value, sometime be more than the actual value. Okay, so when you take the average of all the readings, fine. So when you take the average of all the readings, what will happen to the random error? What do you think? If you take the average of all the reading, what will happen to the random error? No one. It get mitigated, right? So exactly how many reading you should take so that random error is gone completely? How many reading you should take for mitigating the random error completely? Infinite. Okay, if you take the infinite readings, then there is equal chance that you will be less than the actual value, same number of readings will be more than the actual value also. Fine, infinite reading is the correct answer. Okay, so more number of readings you take, better it is. Okay, the problem is whenever I'm conducting experiment, suppose I'm conducting experiment to find out the time period of pendulum. Okay, now I'm not allowed to use the formula to find out the time period, that 2 pi under root L by G, because that happens in ideal scenario and I may compare it with, but right now when I'm conducting experiment to measure something, I don't know the actual value. For example, I'm measuring the mass of a stone. So if I have to, if someone asks me what is the error in your measurement of taking mass of the stone, I do not even know what is the true value of the mass of stone. With what I will compare my reading and tell you what is the error, right? So that's the reason why first you try to find out the near true value of the experiment, and that is nothing but the average of all the readings, because if you take average, random errors will get mitigated. Fine. So suppose you take these readings, let's say A1, A2, like this, you take multiple reading up to n readings you take. Okay, so basically the true value is assumed to be the arithmetic mean of all these values. So the mean value is the true value, 1 by n, a1 plus a2 and so on up to an. Fine, this is your true value. Okay, now if this is my true value and you ask me to quantify the error here, the sources of random error can be many. Okay, you cannot just say that the least count error is my maximum error. Okay, random error can come from anything. It is so random. So you should not calculate the random error from here and there. Okay, so rather than that, we will find out the random error in this way. First I find the true value, then I will find the error in the reading 1. Error in the reading 1 is basically mean value minus 1, the first reading, right? The error in reading 2 is mean value minus A2. Like this, I will find out the all the errors. Error in reading n is AM minus AN. Okay, so like this, we have found out the error in all the readings by assuming that mean reading is the true value. Okay, now I am asking you to find out the overall error in the experiment. The true value is, let's say, AM, right? AM is a true value which you have found out. You need to write something here, plus minus some error. What is that? How to write that? Whether to write delta A1 here, delta A2, delta AN, what should I write? Should I take the mean of all these errors also? Can I do that? Can I say that the error will be equal to delta A1 plus delta A2 and so on divided by n? So suppose I take infinite reading, the mean of delta AM will be what? For infinite reading, what is this value? It will be exactly 0, right? It will be exactly 0. So that is useless. I mean, that should not be true. Okay. So in order to find error, I will make sure that I take mod of the error. Okay. Mod of these. Some errors will be negative. Sometime A1 will be more than AM. Sometime, let's say A2 is less than AM. So this could be positive value. This could be negative value and so on. So that's why when I'm finding the error, I'm taking mod of the every error and then taking the mean of it. So this is mod of delta A mean. So this is how you write the value A mean plus minus mod of delta A mean. All right. This is the value of A. Like this, you write it in your lab records. Okay. Now this value delta A mean, the way we have calculated, this is called absolute error. This is the absolute error. Okay. What is the doubt? Even if we take infinite reading till be 0, it will be 0. No, it will not be 0. Mod of any number is a positive quantity. Okay. Mod of A1 a positive quantity, mod of A2 a positive quantity. So how will it be equal to 0? Average of the positive numbers. Okay. So all of you, oh, divide by infinity. Yeah. You can say that, of course. But then even numerator has infinite terms. Okay. Even numerator has infinite term. So it is, you can say infinite divided by infinite. It is indeterminate form. So you have not learned the limits, I think. So, but then unnecessary, let's not discuss that. It's not required. Even numerator will have infinite terms. Okay. A short answer to that. So now tell me here that if suppose your home and your school, the distance is, let's say, 10 km. Okay, you have measured the 10 km distance from school to home. The distance is 10 km and the error is 1 km. Okay. Now from Earth to Moon, what is the distance? Do anyone remember, or we can just assume something? Nobody knows. So let's say a couple of lakhs of kilometers. Okay. Let's say it has 3.8 lakh kilometer. We don't know exactly how much it is. Suppose it is this much. The error is, let's say, 1 kilometer. Okay. Now tell me which reading is better, as in more accurate, more precise. Which one? Second reading is better, right? Second reading is better, but the amount of error is same in both the cases, right? In both the cases, the error is same, 1 kilometer. So this is a very important learning here. When we are comparing the two readings, you do not compare their absolute errors. It is like, for example, one person has written board exam, other person has written J advanced, and both are comparing their absolute marks, which is useless. Okay, you can't compare 1 kilometer of error in 10 km with 1 kilometer error in 3.8 lakh kilometer. So when you compare the two readings, you don't compare the absolute error, you're comparing its relative error. Fine. So relative error is this. All of you write down. We are comparing its relative error. So relative error is the absolute error divided by the true value, like this. So what was the relative error in case number 1? 1 by 10. 1 by 10 was a relative error for 10 kilometer, and then 1 by 3.8 into 10 raised to the power 5. This was a relative error for the moon. So now you can say that the relative error in school case is much more than the relative error in the case when you are measuring the distance of moon. Okay, so relative error is more meaningful when you are comparing the two readings. Fine. Similarly, there is something called percentage error. What do you think it is? What should be the formula? Percentage error. No one. Relative error into 100. Okay, simply. So it is delta A mean divided by A mean into 100. This is what it is. Okay, so we have just learned how to calculate the error and how to write the readings. Once you get the value of error, you write the reading like this: A mean plus minus delta A. This is your error and this is your true value. Okay, so let's take an example and see how to apply it. So these are very simple examples. Don't expect very difficult questions also from this chapter anyways. Do this, but you should do the calculation your own, because everybody knows how to solve it. The moment you start using calculator, you're fooling yourself, nobody else. Okay, acha. Anybody got the true value? The mean value of the readings. 2.624. 2.624 seconds. Correct. Oh, there is 2.8 also. So what is the error now? Delta T mean. Error. Anybody got error? No one? Roughly you can tell. No one? Okay, you will get it as 0.11 second. Okay, probably it is too much of calculations. Okay, it's fine. This is the error. So the way you write the reading is like this: 6.2624 plus minus 0.11. Okay. Now you will learn soon that you don't need to write up to 3 decimal places. But right now we haven't learned that concept. So we are writing whatever it is coming here. Okay. So relative error is what? Relative error. Relative error is 0.11 divided by 2.624. How much it is? What do you think? This you should calculate. Rough calculation. Roughly you just tell me what it is equal to. 0.04. 0.04. So this is the relative error and the percentage error will be 4%. Okay, 4% of the reading, every reading you take, that is the maximum possible random error. No, 0.04. 0.6 cannot be relative error. If it is 0.6, the percentage error is 60%. So what 60% error is too much. Okay. All right. So these are the basic concepts of how you quantify the errors. Fine. Let's move forward. So next, the concept is combination of error. First, write down this thing, then I'll discuss about it. Combination of errors. Okay, so the issue is that sometimes we whatever we need we calculate it directly. Suppose I just need to find out the mass of the uh, stone. I find out the mass of the stone by experiment and I know what is the error. Okay, but the problem is story doesn't end there. Suppose I need to find out, let's say, the force acting on the mass, and I cannot measure the force directly. Then what I'll do? First, I will measure the mass, then I'll measure the initial and final velocity, then I'll measure the time taken to change the velocity. So I will calculate what is the acceleration from change in velocity and time. I calculate the acceleration, then I'll multiply that acceleration with the mass, and then I'll get the force. Now, how much is the error in the force? This is what we are trying to do here. Okay, force I'm not measuring directly. I have measured mass. The error is in the mass. I have measured velocity and time. The errors are in velocity and time. I have calculated acceleration, so there will be an error in the acceleration also, but I don't know how to do that. So then I multiply mass with acceleration. Mass has error, acceleration also has error. I have multiplied these two quantities. So when I multiply, what happens to the error? Okay, that is what we are learning here. Okay, so this combination of error is an important topic wherein you are trying to derive something from the measured values. Okay, so the example that I've taken, I'll write it down so that you remember it. Force is equal to mass times delta V by delta T. Okay, so using the instrument you have measured, we have measured mass with the error of delta M. We have measured the change in velocity with, let's say, error of small delta V. Both are delta only, so it may be confusing. Then we have measured delta T with an error of plus minus small capital delta T. These are the errors in mass, delta V and delta T. Now when I calculate the force, I have to write F plus minus delta F. Okay, the value of F I can directly get by substituting M, delta V and delta T. But when you multiply, what happens to these errors? These errors, what happened to them? Multiply, divide, add or subtract. This is what you are going to learn. Okay. So the first thing is error in sum and differences. Write down error of sum and difference. So suppose I have a value of A. I'll write it as, that's fine. Capital A is small a plus minus delta A. This is A. Capital B is small b plus minus delta B. All right. Now I need to find out Y, which is equal to sum of A and B. Okay. So when you add it up, it will become A plus minus delta A plus B plus minus delta B. And you can see here, it becomes A plus B plus minus delta A plus minus delta B. So what is the error in Y if I write Y as small y plus minus delta Y? So delta Y will be what? Type it out quickly. No one? All of you? Correct. So the value of the error, maximum possible error you have to calculate every time. So delta Y is delta A plus delta B. Okay. Now if I say that Y is equal to A minus B, suppose I subtract the two values. Now tell me what is the error in Y? All of you calculate what is delta Y, what it will be equal to. Everyone should do it. Okay. Others? Fine. So now many of you are saying delta A minus delta B. The answer is delta A plus delta B only. and this is how it is. A plus B, you'll get it as plus minus A. You might be wondering it is minus plus delta B, right? This is plus minus delta A minus plus delta B. Now plus minus and minus plus both are same. It doesn't matter. It doesn't mean that when delta A is plus, delta B is minus. It doesn't mean that. Okay, plus minus means that it can be randomly plus A at max, or it can be minus B. Okay, so it can be both sides. If I have to ask you what is the maximum possible error in this case, when both will be positive, right? Or both will be negative. So delta A plus delta B over here also. So whether it is summation or subtraction, in both the cases, the errors will get added up. Okay. All of you clear, right? No doubt with this thing. Anyone has any doubt? Okay. So if temperature T1 is 20 degrees Celsius plus minus 0.1 degrees Celsius and T2 is 50 degrees Celsius plus minus 0.1 degrees Celsius, then what is T1 minus T2? All of you? What it is? Correct. Others also quickly answer it. Nice. So T1 minus T2 will be minus 30 degrees Celsius plus minus 0.2 degrees Celsius. Okay, the errors gets added up. Okay. So this is with respect to the summation and subtraction of the errors. Now let's see what happens to the error when the two readings are multiplied or when the two readings are divided. Okay, write down. Error in product or exponent. See, division is nothing but a product only. Like A divided by B is multiplication between A and 1 by B. So I'm not writing product divided by division. Sorry, product and division. I'm just writing product and exponent. Okay. All right, same example we'll take. Suppose you have a reading A, which is small a plus minus delta A. You have a reading B, which is small b plus minus delta B. Okay. The reading Y is basically A into B. So A into B is A plus minus delta A multiplied by B plus minus delta B. So all of you expand it and tell me if I can write it as Y plus minus delta Y, then what is delta Y? Do it, all of you. Open the brackets. It will be AB plus minus A delta B plus minus B delta A plus minus delta A delta B. Plus minus delta A into plus minus delta B doesn't become plus delta A delta B. It remains plus minus only. Because once delta A is positive, delta B can be negative. They are independent. Okay. Now tell me, what is the value of y? Y is what? Small y is what? Out of these expressions, what is small y? Small y is A into B. The actual reading multiplication, the true reading A and B, you need to substitute in this formula to get the true reading of the y. The errors will be dealt separately. So y is equal to A into B. Fine. So delta y, I can say maximum value of delta y is A delta B plus B delta A plus delta A delta B. And do you think delta A into delta B will be very small? It will be a very small value. What do you think? This delta A into delta B, will it be very small or not? Right? Compared to B into delta A, this value will be very small. So you can ignore this value. So this becomes 0. Okay. So you will have delta y is equal to A delta B plus B delta A. This is the true value, absolute error. Now you can write it in a better manner also, but by just dividing A into B both sides. So I am dividing A into B this side, and A into B is Y also. So you can see here delta Y by Y is equal to delta A by A plus delta B by B. Fine. So when the two values, two measured values are multiplied, their relative readings or their relative errors gets added up. Clear to everyone? Is everyone clear? Okay, fine. Now let's take another scenario. Like for example, if I have y is equal to a square. Now tell me, what is the error? How do you write delta y? Delta y, how do you write? The hint is you can write a square as a into a. Correct. Delta y by y is equal to 2 times delta a by a. So if it is exponent, exponent comes in front when you calculate the relative errors. And not just if exponent is, let's say, is an integer. Even in this case, where y is equal to a to the power 5 by 2, okay, you haven't learned the binomial theorem. You'll understand from that later on, but right now take it as it is. Even if the exponent is a fraction, you'll get it like this: 5 by 2 delta a by a. It is as simple as that. I hope it is clear to everyone. Fine. Now tell me, what is the error in this formula? Y is equal to a divided by b. The hint is a divided by b can be written as a into b to the power minus 1. All of you. How it is 2 dA by A? How it is 2 dA by A? See, A square can be written as A into A. We have just learned if two readings are multiplied, their relative errors get added up. So delta A by A plus delta A by A becomes 2 delta A by A. Got it, Ansh? Now tell me the error in A by B. A by B, what is the error? No one? It is A into B to the power minus 1. Acha, tell me what is the error in 1 by B, which is B to the power minus 1. What is the error? Delta Y by Y in this case will be what? Exponent has to come front. Okay, now still there is this issue that people are saying minus delta B by B. The error can be on both sides. Error can be on both sides. You don't know whether it is plus or minus. Okay, so the simple thumb rule is errors never get subtracted. Never. Understood? For example, if this is the case, let's say y plus minus delta y is equal to b plus minus delta b. If I bring this delta y over there, then also that delta y will not get subtracted with delta b. It will get added up. Errors never get subtracted. Never. Because you are trying to play safe. You are trying to find out maximum possible error. So delta y by delta y in this case will be simply delta b by b only. So in this case, what is delta y by y? All of you. Delta y by y, what it will be equal to? A by b. Ansh got it. Others, quickly type in. All of you, type in. Waiting for you. It will be delta A by A plus delta B by B. Errors never get subtracted. Any doubts to anyone? Anyone has any doubts? Quickly type in. Anyone has any doubts? Anyone has any doubts? Quickly type in. Yes or no? Do you have doubts? Yes or no? Is it clear? All right. Yeah, Kshitiz, correct. You multiply y, na? Y is A into B. If you want to find out delta y, cross multiply y. Y is A into B. So delta y is B delta A plus A delta B if you want to find out delta Y. Okay, so we'll take one more example. Let's say Y is equal to, all of you write down, wait, sorry. I was having A into B in my mind. So yeah, you have to multiply A by B. Y is A by B. So multiply A by B here. Okay? Not A into B. A by B is Y. That you have to multiply. It is simply cross multiplication, Kshitij. Okay, all of you do this. Suppose Y is equal to A to the power 2, B to the power 3 by 2 divided by C to the power 7 by 3. Then you have to tell me what is the error in Y. Delta Y by Y will be what? All of you do this. Let me know once you're done. You don't need to type in your answers. Just let me know once you're done. Everyone, just let me know once you're done. All right. So delta Y by Y can be written as, let me know once you understood this, delta A by A plus 3 by 2 delta B by B plus 7 by 3 delta C by C. Fine. This is delta Y by Y. All of you got this? You can see it is straightforward only. It is simply straightforward. No one has any doubts, right? Anyone has any doubt? Okay, let's take one example here. This one, solve it. Yes, Arya, what is the doubt? Why, Arya, why you think so? The coefficient of C is 7 by 3, right? You can say minus 7 by 3. So that's why 7 by 3 will come out. Okay, I can see many of you have answered already. 7% is the correct answer. Yes. Arya, understood? All right, so here V is 100 plus minus 5 and current is 10 plus minus 0.2. This is ampere, this is voltage. Find the percentage error in the resistance, right? Resistance is basically V by I. So since it is the ratio, which I can write it as V I to the power minus 1, from here delta R by R is equal to delta V by V plus delta I by I. Fine. So delta R by R. Meanwhile, I also wanted to find out the absolute error. What is the absolute error? Those who have got the 7%, find out the absolute error also. Delta R by R is delta V. Delta V is what? 5. This is delta V divided by 100 plus delta I, that is 0.2, divided by I, which is 10. This can be written as 7 by 100. This is the relative error. Percentage error will be this relative error multiplied by 100, which is 7%. Absolute error. No, Arya, what is that? No, it will be c to the power minus 7 by 3 only. When it goes in numerator, simply minus sign will come in. Minus 7 by 3. It is not 7 by 3 minus 1. Get the value of absolute error. What it is. What is the value of R? R is what? R is the ratio of the true values. 100 divided by 10. So 10 ohms. Fine. Delta R by R is 7 by 100. So delta R is 7 by 100 multiplied by 10, which is 0.7 ohms. So if you want to write the reading for R, you should write like this: 10 plus minus 0.7 ohm. So I'll take a small pause here. Tell me if you have any doubts. Type in yes or no. Things should be very clear. These are the basics. If you do not understand this, then things will become little difficult going forward. Everyone. Tanmay Peter, any doubt? Sanmukh, Rubhav, Gurman. Yeah, I'm going to give another question. Not exactly like this, something different. All right, so let's take another question as requested by Rubhav. Sir, can you repeat why error of a square is 2 delta a by a? Of course, here it is. So y is equal to a square. Suppose I have to find the error. I can say that y is equal to a into a. From here, delta y by y should be actually equal to delta A by A plus another delta A by A. So which is what? Sorry, delta A by A, not by 2. Which is what? 2 delta A by A. Right? We have learned about how to take care of the error when it is multiplied. So that's why. All right. So one more question. This one. What is the 1 second resolution means? 1 second resolution means the least count error is 1 second. This is what it means. The minimum reading that instrument can have is 1 second. So you can say the error in measuring the instrument has a least count of 1 second, or the error is 1 second. Understood? Whenever someone is asking about accuracy, accuracy is always relative, so you have to give percentage or relative error. Okay, others? This is the difference between class 11th and 10th. Every numerical will be unique in its own. You cannot learn one type and start same knowledge to solve the other one. Okay, so develop this habit of doing new things. Solve it. Think over it. You'll be able to solve it anyway. It is not a very difficult one, anyways. Should I solve it? Should I solve? That's okay. At least you tried. Getting wrong answer is perfectly fine, and it is actually good that you have done it, you got some wrong answer, it is good. Don't worry about it. Yeah, it's fine. All right, so I'll attempt it now. All of you focus here. So I know that the time period of oscillation, the formula is this: T equal to 2 pi under root L by G. Okay. This is the time period of the oscillation formula. The error cannot be close to 100%. So if you're getting such high percentage, probably something is wrong. Okay. Listen here now. Time period is 2 pi under root L by G. Measured value of L is given. The error in L is given. And the time for 100 oscillation is given. The formula you have is the time for one oscillation. The formula is not time for the 100 oscillation. Formula is time for only one oscillation. So you need to modify the formula for 100 oscillation because you're measuring 100 oscillation. You're not measuring one oscillation. So you can't use this formula. So for 100 oscillation, the formula should have been 200 pi root over L by G. This should be the formula. Now I'm measuring T100, I'm measuring L. I need to find what? The relative error in G. Now two variables I'm measuring, third variable I have to find relative error. So now I can use the definition of the relative error here. So if I write it, the error in the 100 oscillations time can be written like this. This is equal to what? The error in 200 pi divided by 200 pi plus what? Everyone, plus what? Plus, what should I write here? How? Yes, 1 by 2 delta L by L plus half delta G by G. Got it? Fine. This is L to the power half. This is G to the power minus half. So half will come out. Exponents, right? Now tell me, what is the error in 200 pi? Everyone, what it is? Error in 200 pi is no error. It is a constant. It is exact value. It is not a measured value. Fine. So this is 0. This is not measured. This is exact. Fine. So that's the reason why delta T 100 by 100 is half of delta L by L plus half of delta G by G. It should be 1. What should be 1? Delta is error. Delta in 200 pi is 0. Numerator is 0. Denominator is 200 pi. Okay. Okay. So delta T100 is 1. First, I'll modify it to find out delta G by G. So can you modify it? Tell me what is delta G by G? Modify that formula. Delta G by G is what? Everyone. Delta T100 by T100 into 2. Then what? Minus of delta L by L. Is this correct, all of you? Is this correct? I will run a poll. Tell me, is this correct? Is this expression correct? Yes or no? Is this correct? Only one person hasn't taken the poll. Quickly take it. Is this correct? All right, so there is a confusion here. So those who are saying, no, this is not correct, tell me what is the mistake? What's the mistake in this expression? Correct. It should be plus. It should be plus over here. Errors can never be subtracted. These are errors you're dealing with. Fine. So delta G by G is 2 times delta T100 is what? 1 second resolution, and the measured time is 90 plus delta L is what? 1 mm is 0.1 centimeter divided by 20 centimeter. Fine. So basically, when you're dividing it, both numerator and denominator should have the same units, so that when you divide, the units get cancelled away. Okay. So this is equal to 2 by 90 plus 1 by 200. This is delta G by G. Anyone calculated how much it is equal to? Anyone has got it? No one? Okay, I'll just quickly find out. 2 divided by 90 plus 1 divided by 200. So this is 0.027. Fine. So 2.7 percentage of the error. 2.7% of the error. Okay. Is there any doubts? Now I'm going to the next part of the chapter. So this is one section that talks about the errors and how you deal with, how you calculate the error, and if errors are multiplied, divided, added or subtracted, then how you have to take care of it. So is there any doubts in this particular section? Then I'll go to the next one. No doubts. Okay, let's get into the next topic. Next topic is little vague. Okay, why it is vague? Because it is not mathematics as such. It is actually just a concept wherein you're trying to write the readings and try to signify its accuracy in a way. As in, I just told you, right, 2.0 is different from 2.0000. Okay, so if you want to write your values like this, there are few set of rules that you have to follow. So we are going to understand what are the rules, how 2.0 is different from 2.0000, and that is what this topic is. The topic's name is significant figure. Write down. All right. So significant figures are basically, this is a concept which is used to represent any reading as such. So it will be soon clear what I mean here. So all of you first write down few sentences here. That reliable digit plus first uncertain digit is significant figure. So basically, if I write down 2.00, the reliable digits are 2 and 0, these two. I'm not sure whether this one, the second 0, is exactly 0 or it can be 1 also. Fine. So 0 is, at the end, the 0 is unreliable or uncertain. because of the errors. So if you write like this 2.00, it automatically means the error in the measurement is 0.01. The way you are writing it, you don't need to write down plus minus 0.01. Fine. So this is another way to write down the the readings as such. Fine. So that's it. So there are certain rules that every time you write some readings and somebody asks you how many significant figures this reading has, you need to follow these rules and then answer that question. Fine. So please write down all non-zero digits are significant. All non-zero digits are significant. Okay. There is no ambiguity. If there is a non-zero digit, that has to be significant. Fine. There is an ambiguity with zero, whether zero is significant or not. So that depends on how zero is written. So zeros between two non-zero are significant. Okay. Then zeros between two non-zero are significant. Fine. If number is if number is less than 1, less than 1 as in 0.012, like this. Okay, something like that. If number is less than 1, zeros to the right of decimal but left of first non-zero are not significant. So I'm talking about this zero, this one. This zero is not significant, which is right of the decimal but left of the first non-zero decimal. Okay. Okay. Write down trailing zeros in a number without decimal are not significant. Now we cannot debate that why they are not significant, why they should not be that. These are just laid down rules which if you follow, people will understand what you mean. Okay, they will understand how accurate your readings are because they are also following the same set of rules. As such, there is no hard coded or reason out process wherein these rules are, these are not the law, they are just rules which are laid down. There are no logic as such, but then yeah, you can reason out like this. Suppose somebody asks me how far Hyderabad is from Bangalore. What I say roughly 500 kilometers, right? I never say 525 kilometers, 0.3, 525.3. If I say like this, I exactly know how far hold on, Ansh. If I tell the distance of Hyderabad from Bangalore, somebody like if I say it is 500, you'll immediately automatically understand that this guy is not sure whether it is 500 or 550 or 525. I'm not sure. I'm just telling you 500, isn't it? That kind of message goes. But then if I tell you the distance of Hyderabad from Bangalore is 525 kilometer 30 meters, then you'll be like, oh, this guy know exact value. So all my figures are significant. But if I say 500, the trailing zeros, two zeros are uncertain. So it is just a way to communicate. Trailing zeros are the zeros coming at the end. These three are trailing zeros. Okay, they are not significant. Getting it? I hope all of you have understood these 4 rules. There is one more rule. All of you write down trailing zeros in a number with a decimal place. What do you think? It will be significant or not? Trailing zero in a number with a decimal place will be significant or not? All of you answered. Trailing zeros in a number with a decimal will be significant or not? It will be. Correct. Write down. Trailing zeros. All of you write down, then you can ask doubts. Stop typing in. Actually, I'm writing at the bottom. So if you type in, the window get lifted up. So I can't write them when I'm writing at the bottom. Trailing zeros. So if you have to irritate me, you can do that. Like if I'm writing at the bottom, you can start typing in messages. So trailing zeros in a number with decimal place are significant. Okay, if I tell you that the length is 2.000 meters, you'll be like, oh, this guy know how accurate this is, right? But if I tell you the length is 2000 meter, then you'll be like, oh, this guy is not sure whether it's 2000 or 1998, like that. Trailing zeros are the zeros at the end. If zeros are at the end, understood, Oro? Trailing zero, like for example, this one, 523.43000. These are the trailing zeros. By the way, how many significant figures this number has? How many? This number has how many significant figures? Trailing zeros can be without decimal also. First tell me how many significant figures here. 8 significant figure it has. 8. All non-zero are anyway significant. 5, 2, 3, 4, 3. They are significant because they are non-zero. So you can blindly say that since they are non-zero, they are significant. 5, 2, 3 and 4 and 3. They are significant. These are the trailing zeros. The trailing zeros are coming after decimal place. These 3 are significant or not? They are significant. So 5 plus 3 total 8 significant figures. I think you guys have few doubts. Please type in your doubts. Then only I'll move forward. Quickly ask your doubts. Those who have said 5, have you understood why it is 8? All of you understood why it is 8? If it was 500, this was a good question. Let us talk about that. Tell me, in this case, 500.43000. How many significant figures this has? 5, 4 and 3, they are significant. Okay, these two zeros, are these significant? Why they are significant? Which rule you are applying? Between two non-zero, between 5 and 4, between two non-zero, all the zeros are significant. So, no, not last rule, Pradyun. Last rule is for trailing zeros. Last rule is for the trailing zeros. These two zeros are between the two non-zero ones. The second rule we are applying here. Zeros between two non-zero are significant. Understood? Hold on. Now these three zeros, are they significant? They are significant. Understood? So it applies even across the decimal place. Hold on. No, we are not talking about error here, Sitij. I'm just calculating significant figures. Okay. Acha, let me just quickly talk about the rule again. All of you, I think the few of you have little confusion, so we can't move ahead like this. So all of you understand that non-zero will be significant. The only problem is zeros, whether zeros are significant or not. Fine. So let's discuss about zeros. So zeros, when they will be significant? Achha, don't ask me why they are significant. Okay, these are just rules. They are hypothetical rules. We can't reason out why they are significant, why this is that and that. No, we are not discussing that. We are discussing only rules here. Okay, so significant. Zeros are significant if between, write down, between two non-zero, they are significant, and if they are trailing zeros after decimal. Only in these two cases zeros are significant. Fine. And when it will be insignificant, when it will be not significant, everyone. When it will be not significant, trailing zeros without decimal. The example, this one, 5,000. How many significant figures this has? Everyone. How many? Are 4 kaise, Oshik? How it is? Only one. These are trailing zeros without decimal. Yes or no? Oshik Dar. Trailing zeros without decimal. So these three zeros are not significant. Okay. Now tell me how many significant figure this has. 5,000 divided by this. Sorry, 0.00. How many? 3. Right? It has 3. 1, 2, and 3. These three zeros are not between two non-zero. One side is 5, other side is 0. So this rule doesn't exist. This rule doesn't apply here, the first one. So only 5 is significant and after decimal 2 zeros are significant. Understood? Trailing zeros after decimal. यही तो है. The last rule only we have applied. These two are significant. These two. This rule only we applied, right? Trailing zero with decimal. Trailing zero with decimal ही तो है रे. This is decimal. Trailing zeros are there with decimal. What are you saying, Sutej? Everyone understood? All of you? Last one are significant. Ansh, why there is so much confusion? 2.00. How many significant figures this has? How many? It has 3. 1, 2, 3. Trailing zeros after decimal are significant. Okay. Acha, tell me how many significant figures pi has? A number pi, how many significant figures? Infinite. Okay. Every exact value, every constant has infinite significant figures because I exactly know what it is. A number, if you say a number 2, if it is a constant, it is actually 2.000 up to infinity because it is exactly 2. Fine? All right. All right, guys. So let us move to the next topic now. Enough of this. Those who are still facing trouble, please contact me after the class, or you can get in touch, with me, or you can watch the recordings itself. Anyways, let's move forward. Now that we have learned about the significant figures, here it is one example I'm giving you. You will be surprised to see that these rules are not accurate, as in they are ambiguous. Okay. For example, let's say I say 5. Let's say I say that I have a number. I have 5.00 meters. How many significant figures this has? 5.00 meters. 3. It has 3, right? Now, if I convert it into centimeters, it will become 500 centimeter. Now, how many significant figures it has? 1. Right? It has 1. So, the way we are, writing the rules of significant figures, they are giving two different results by just changing the units. It should not happen, right? So changing units should not change the accuracy. So these rules are ambiguous, and hence a scientific notation was introduced. A scientific notation was introduced to make sure these ambiguity are gone. Okay, what is scientific notation? It says that 2.00 is different from 2. What is problem? What is the problem? Where I have said that they are equal. They are different, na? So what? What is the issue, Ansh? What is the doubt?
Sir, but if they are different, then which one is the insignificant one? Like, which zero is insignificant? Because all of them are trailing zeros, right, after the decimal point. So none
all
of them
are significant. Everything is significant. Here you have 3 significant figures. Here you have 6 significant figures.
Oh, so that's why they're different.
Huh.
Okay. So I thought okay, got it, sir.
There are two different readings. One,
Yeah.
2.0000 is taken from a very, very precise instrument. That's why you are sure about the 6 decimal place also.
Oh, okay, sir. Got it.
Anyways, scientific notation is introduced. So rather than writing numbers like that, you write it like that: A into 10 raised to power B. You might have seen that many times the values are given like that, 3.2 into 10 is power 6 meters, like that. So when you use 10 is to power like that, if you use, you're writing it in a scientific notation form. Fine. So every time you convert units from meter to centimeter, factor of 10 will change. It is assumed that you are using the units which are factor of 10 only. You should not start using inches, then feet, then your local units. No. You have to use when you convert the units, you are using the units which are factor 10. For example, meter to centimeter, factor of 100, like that. Anyways, so the number A should be greater than 1 but less than 10. Greater than or equal to 1 or less than 10, and B belongs to a real number. So if you write your readings like that, significant figures in A into 10 is to power 6, sorry, A into 10 is power B. I've just read B as 6. Take a break. So A into 10 is power B. If you have to find out what is a significant figure, you count significant figures in A. Significant figure in this is equal to significant figure in A. So now when you convert units, only factor of 10 will change, A will remain same. So that way you can get rid of this kind of ambiguity wherein if you change the units, the number of significant figures changes. Okay, any doubts, anyone? Anyone has any doubts? What if B is negative? So what? Let B be negative. 10 is power minus 200. It is perfectly fine. For example, mass of electron 9.31 into 10 to minus 31. How many significant figures it has? 9.31, 10 is power minus 31. How many? 3. It has 3. Okay. Fine. चलो चाहिए बताओ 1.001. How many significant figures this has? 4 it has. Easy, right? These two zeros are between two non-zero. So they are significant, and non-zeros are anyway significant. So two zeros are significant and two non-zeros are anyway significant. So total 4 significant. All right. Okay, so I hope things are very clear, crystal clear. Anyone has any other doubt? This is the time to ask quickly. Quickly type in, you have doubts or not, yes or no. Anyone has any doubts? All right, so we will take a break, much needed break for me at least. I was reading BS6. So right now it is 6 p.m. We will meet at 6:15. Okay. Yes, Priyam, correct. You're correct. All right, so this is your break. Go and take it. Come back in time. Priyam, that is correct. All right, so I hope all of you are back. So you are able to hear me, right? Clearly? All of you? Okay. All right, guys. So we have learned about the significant figures just now. It is a little vague concept. This is not how usually physics and mathematics concepts usually are, but this is one of such concepts. Okay, because we are talking about a random error, so even the rules are little bit having some randomness. Okay, so let us proceed. Now that we have learned about the significant figures of individual readings, okay, what will happen if two readings are added, divided, multiplied, or subtracted? Significant figures will remain same. Should we increase significant figure? Should I decrease the significant figure? What rule should we follow? So that is what we are going to learn next. So before that, we have learned about the how we deal with combination of errors. What happens to the error if two readings are multiplied, added, subtracted? Now we will learn what will happen to the significant figures if two readings are added, multiplied, or subtracted, like that. Fine. So write down rules for arithmetic operations for significant figures. Rules of arithmetic operations for significant figures. Now again, these are rules, so we'll follow it as they are. Okay. So the first rule is with respect to multiplication and division. Fine, write down. Multiplication and division. The rule says this: the final result when you multiply or divide, final result should retain as much significant figures as there are in original number having least significant figures. This we will understand with one example, otherwise it will not be so straightforward. Wordings are complicated. Suppose mass is given as 5.42. Okay, the volume is given as 2 meter cube. 2 meter cube is the volume and this much is the mass. So density is what? All of you calculate the density. Density rho is what? The volume is 2.0, not 2. 2.0 meter cube. Ansh, have you multiplied mass with volume? Density is mass divided by volume. Silly error, huh? Mass divided by volume, how much it is? All of you, please tell me the answer. And use this rule when you're telling me the answer. Use the rule. How much is mass divided by volume in this case? You'll get 2.71, right? But which number has least significant figure? Volume or mass? Which has a least significant figure? Volume or mass? Volume, how many significant figure volume has? 2. So final answer should also have only 2. So 2.71 is not correct. 2.7 is the answer. So we have this habit when we divide one number from other, we keep on finding the trailing digits. 2.7, 1, 5, 4, like that we keep on finding. So all that is useless. I am not even sure about the second digit. Why I should find the fourth and fifth, sixth digits? So this is why we have to stop with number of significant figures whichever original value has at least one, we need to only find significant figures till that. In this case, volume has least significant figure 2, mass has 3. So mass divided by volume should have only 2. The least one is for the volume. I hope everyone is very clear. Okay. Sometimes you get things like this. Mass is 5, volume is 2. Then what is density? Density is what? 5 by 2, which is mathematically 2.5. Mathematically 2.5. But I can't write up to 2 decimal. I can't have 2 significant figures. I need to make it a single significant figure, 2. Okay. Now sometimes you need to round it off. Sometime 5 will carry forward. We will talk about when and how number 5 will be carry forward later on. But I hope things are very clear. If 5 is a reading, 2 is also a reading. 5 by 2 is 2. It is not 2.5. This is not mathematics. Okay. No, 5 is not a number. 5 is a reading, Sitej. It's a reading. If 5 is a number, then it has infinite significant figure. But I have measured it as 5. I have not been given it. Okay, so we'll talk about rounding rules also. Let's first discuss about the addition and subtraction rules as well. Write down addition and subtraction. The rule is this, that final result should have same number of decimal places as there are in original number having least decimal places. So in multiplication and division, we have to take least significant figures. In case of addition and subtraction, we need to take least decimal places. Okay. So for example, 0.5 minus 0.48. What do you think this is? Suppose 0.5 is one reading, 0.48 is another reading. When I subtract, what should I get? Correct. The mathematical is 0.02, but right now it has two decimal places. It should have only one. So answer is 0.0. Okay, answer is 0. We are talking about readings. I have no confidence in this 0 itself. How can I say the second decimal place is 2? So I need to drop it off. So now tell me this 0.504 minus 0.2, what it is? If these are two readings, correct, 0.3. It should retain least decimal place. Mathematically, it is this. If I use the above rule, I need to write it as 0.3. Okay, so this is how you take care of the significant figures in case of arithmetic operations. 4 basic operations: addition, subtraction, multiplication, and division. Okay. Now comes the rounding off rule. Write down rounding off the uncertain digit. Write down rounding off the uncertain digit. Suppose in order to use the above rules, you have to drop few digits. For example, in this case, you have dropped 0 and 4. Over here, you drop 2. So there are few rules to drop the digits also. Fine. So if it is if number is between 1 and 4, you just drop it off. Drop it. Okay. If number is this is 1, 2, 4. I'll give you examples also. Write down, please write it down. If number is between 6 to 9, okay, increase the left digit by 1 and remove. Okay, the example for the above one is 2.44. 2.44 is 2.4. Suppose you need to round off 4. So 4, you just need to drop it. Nothing will happen. Okay. Over here, the example is 2.46. If it is like this, you can write it as 2.5. When you are removing 6, you need to increase the adjacent digit by 1. Rules are clear to everyone? These two rules are clear? Any doubts in these two rules? Rounding off rules? Simple, right? So this is the rule for the rounding off. But then with respect to number 5, how to round off 5? There is an ambiguity. Okay, because 5 lies exactly in middle. Fine. So 1 to 4, there are, if that lies, you need to just remove it. 6 to 9, you just need to increase the adjacent digit. But if it is 5, then these are the rules. I'll just give you an example rather than using words to explain, it will be better. 2.35 will get rounded off to 2.4. Okay, 2.45 will just get rounded off to 2.4. Another example, 4.55 will be 4.5. 4.6 it will be. 4.65 will be equal to 4.6. Fine. So the rule is for number 5, if the left digit is odd, add 1 to it. Okay, but if the digit on the left is even, you drop it. Okay, without increasing it by 1. Fine. These are the rules just to create a balance, Ansh. Okay, we can't reason it out. There has to be a balance. There has to be some rule. Otherwise, what will happen? Half of the people will say, okay, I'll increase by 1. Half of them will say, no, I'll not increase by 1. So that everyone follows the same thing. That is why this rule is there, as in to remove the ambiguity. Okay, because 5 lies in exactly in between. So there has to be something like this which everybody follows. Understood, Ansh? Otherwise, Ansh will round off, Kshitij won't round off, then Oro will round off, then somebody else won't round off. So nobody knows exactly when to round off, when to not to round off. Okay. Anyways, so this completes the this completes the discussion on the errors, and I tried to make it as interesting as possible. But yes, it is highly theoretical and not. I mean, frankly speaking, it is not so interesting also. But this is what it is, and it get asked in the exam, so that's why it is important as well. Now we are getting into something interesting finally, and this section of the chapter is called dimensional analysis. And if there is a question on this chapter in competitive exams, then 90% of chance it will be on this particular section that we are going to deal with it now. All right, so here it is, guys. Write down dimensional analysis. Likho. Dimensional analysis. Okay. Now, dimensional analysis is an analysis done with respect to dimensions. What are the dimensions? I discussed at the start of the chapter, there are 7 dimensions of the universe. Fine. Mass, length, time, temperature, current, amount of substance, luminous intensity. So these are the 7 dimensions. So can I use this 7 dimension to do some sort of analysis? This is what dimension analysis is. Okay. Now, in order to do some analysis using dimension, I need to know what are the rules the dimension follows. So if I know the rules, then I can use it my own way, whichever way I like, to create some sort of dimensional analysis. Fine. So we will first discuss the few pointers with respect to dimensional analysis. Fine. The first pointer is, if, write down, if an equation is dimensionally correct, dimensionally correct, what does it mean, dimensionally correct equation? The dimension of left hand side, if it is equal to dimension of right hand side. Okay. For example, v is equal to u plus at. Dimension of velocity is dimension of these two velocities have same dimension, meter per second, and acceleration into time also has the same dimension. Okay, this is what it means. We'll discuss it anyways. Write down, you first please write down. So if an equation is dimensionally correct, it may not be a valid equation. So for example, torque has the same dimension as work, but you can't say torque is equal to work, right? So just because two dimensions are equal doesn't mean that they are equal. Torque and work, they have the same dimension. You can't equate them, but they're dimensionally equal, but not numerically equal. Now, there's a second pointer. If an equation is dimensionally incorrect, it must not be a valid equation. Okay, so the first statement doesn't give us anything. First statement is it may be, it may not be. Okay, but the second statement is a solid statement which tells us something definitive, because there is a this word must. Okay, so every equation should be dimensionally correct. Now, what is this dimension we are talking about, and what is this dimensionally correct, incorrect meaning? That we are going to discuss now. Fine. So how to write dimension of any variable? So dimension of any variable, write down, dimension of any variable can be written in terms of 7 base units. Okay, and usually in mechanics, all dimensions, sorry, all variables can be written in terms of mass, length, and time. You can write it in terms of mass, length, and time, all the dimensions. Now I'll just give you a few examples. You'll understand what is this dimension. It's very simple. So if you have to write dimension of any variable, you need to use a square bracket. So if I write like this means, square bracket means I am saying dimension of this variable. Okay, so dimension of velocity I'm writing. Fine. So dimension of velocity is, I know it is length divided by time, meter per second it is. Fine. So I will write like this: mass to the power 0. Mass has no role in the velocity, so mass to the power 0 it is. Fine. Then length to the power 1, meter is just meter, 1 meter is there, and then time to the power -1. So this is how you write the dimension of the velocity. Is this example clear to everyone? Please type in. Dimension of velocity. All of you understood how it is written? Mass to the power 0, length to the power 1, and t to the power -1. Please type in, all of you. Okay. Now tell me dimension of the acceleration, what it will be. Dimension of acceleration. Acceleration is meter, it is length divided by time square. So m to the power 0, L to the power 1, and t to the power -2. Very good. All of you getting it? All of you understood, right? Example of the dimension of velocity and dimension of acceleration. Fine. Okay. Now tell me dimension of force. Dimension of force should be equal to dimension of mass into dimension of acceleration. What it will be? Correct. Write down first. M L T to the power minus 2. How do we determine if an equation is dimensionally correct? Does LMT need to have the same exponential value? Yes, of course, that's what it is. But I am going to discuss it, Sanmukh. Right now, first, learn this. Dimensional equation I haven't yet discussed. Dimension of force, all of you understood? Dimension of force understood, right? Okay. So now, is dimension of normal force is equal to the dimension of the gravity force? Can I say that? Can I say that? Yes. All forces have same dimension. Same dimension. Whichever force you talk about, everything, whether it is nuclear force, electrostatic force, magnetic force, whichever force you talk about, they will have a dimension of MLT minus 2. If this is not the dimension of the force, then that is not the force. Understood? Now tell me dimension of the kinetic energy. Kinetic energy, what is the dimension? Dimension of mass into dimension of velocity square. It is half mv square. Is there a dimension of half also? Dimension of half is what? Nothing. It's a dimensionless constant. So I can ignore it. So dimensional equation doesn't have half in it. Dimensional equation only has a variable. Tell me, kinetic energy dimension is what? All of you. Aditya, what is the dimension for kinetic energy? Dimension of mass is m. Dimension of velocity square is velocity is Lt minus 1. So velocity square is L2 T minus 2. Fine. So it will become m L2 T minus 2. Okay. All energies in the universe, all energies have same dimension. Whether you talk about potential energy, kinetic energy, whether you talk about potential energy, kinetic energy, electrostatic energy, magnetic energy, whichever energy you talk about, this is the dimension. You just need to find out one energy's dimension and you will get all the energies dimension. That will be same. Yes, Aditya, correct. Okay. Now let's talk about few things related to dimensional equation. Okay. So point number 1 is we cannot, write down, we cannot add or subtract two variables having different dimensions. It is like you can't add velocity with time. Totally absurd. You can't add force with mass. Have you ever seen mass plus force? No, right? So you can only add and subtract two variables which are having the same dimensions. Fine. Now, can I multiply or divide two variables having different dimension? Is it possible? Can I multiply two variables having different dimensions? Possible, right? Because the example is mass time acceleration. Mass is different dimension, acceleration is different dimension. I'm multiplying mass with acceleration. Then mass with velocity is momentum. Mass different dimension, velocity is different dimension. Okay. So with multiplication and division, there is no problem. But if I am adding or subtracting the two values, two variables on either side of plus should have same dimension. This is very, very strong law, and you'll see that using this basic rule itself, you'll be able to solve most of the questions. And we'll be taking up question. Don't worry. You'll see how easily you'll be able to do it. So now taking an example of equation, V is equal to U plus AT. Using this equation, I can create dimensional equation. Dimensional equation is what? Dimension of V should be equal to dimension of U, and this should be equal to dimension of AT. This is a dimensional equation. Dimension of U should be equal to dimension of A into T because you're adding them. Okay, so now you can check dimension of velocity is m0 L t minus 1. Initial velocity also has the same dimension m0 L t minus 1. Acceleration into time has m0, acceleration has lt minus 2, and then you multiply t to the power 1, that is a time, it will come out to be m0 lt minus 1. So this is the dimensional equation. You can see everything has the same dimension, m0 lt minus 1. Okay. All right. So now let's take up one numerical, and you'll see the power of dimensional analysis. So all of these things that whatever we have learned, I will solve just one numerical with you, and you'll understand how powerful the dimensional analysis is. Okay. Anyone has any doubt? This is the time to ask. Anyone? No one? Okay, so let's just tell me few equations which you know already. Few equation. I have written V equal to U plus AT. What other equation you know? Don't tell me S equal to UT plus half AT square. Some other kind of equation. Tell me. Okay. Have you know that impulse is equal to change in momentum? Impulse is force into time. Change in momentum. And have you do you know work done is change in kinetic energy? This one, at least first and third equation you might have heard about. This one we will deal with anyways. Force equal to G m1 m2 by r square. Acha, this is very interesting. See, force equals to G m1 m2 by r square. This is very tricky equation because G has a dimension. Okay, G, even though G is constant, but it has a dimension. So dimension analysis will be very difficult for this particular equation if you don't know the dimension of G. Okay, so these kind of equation we don't deal with in dimension analysis. Now let's check whether this equation is dimensionally correct or not. If this equation is dimensionally correct, dimension of work should be equal to the dimension of kinetic energy. Can you check whether this is true or not? Is dimension of work is equal to dimension of kinetic energy? Then only this equation will be valid. Is it dimensionally correct? Dimension of work is what? Work is force into displacement, force into distance, L. Dimension. Force is what? Mass times acceleration, ml t minus 2 into dimension L. So you will get work done as ml2 t minus 2. This is the dimension of work, and you have already found out dimension of kinetic energy earlier, which was ml2 t minus 2. Dimension of mass into dimension of velocity square. So you can see this equation is dimensionally correct. Then only this equation can be an equation. If dimension of work would not have been equal to dimension of kinetic energy, then this equation would have been invalid. This equation will not be valid because it is a hard rule. Dimension, if there is an equal to sign somewhere, then whatever is on the left hand side and whatever is on the right hand side, both should have the same dimensions. Please type in if you have understood, or let me know if you have any doubts. Okay, let's take up a numerical. You'll understand the power of the dimension analysis. Sir, G m1 m2 by r square. It is correct, Oro. It is correct. The constant G has a dimension, which it is not a dimensionless constant. Okay, that equation is universal law. It is valid in entire universe, not just Earth. Dimension of G will be accordingly. Dimension of force divided by dimension of m1 m2 by r square is the dimension of G. Okay. All right. Do this question, all of you. Assume the formula you don't know. Assume that t pi equal to 2 pi under root L by G. That formula is not known to you. You need to derive that formula by using dimensional analysis. Okay. So try doing it. If you can do it, it will be very nice. You'll never forget dimensional analysis then. Okay, so I hope all of you have tried. Right, doesn't matter whether you got the final answer or not. Somebody will be getting it probably because they have already done something like this. Fine. So if you're doing it for first time, it's okay. Struggle a little bit. I'll just give you a few hints here. The starting point is important. So it is given that time period depends on length. So time period should be proportional to what? L to the power A, let's say. I don't know whether it is proportional to L square, L cube, L to the power half, or L to the power minus half. I don't know. So T is proportional to L to the power A. Okay, and T is proportional to the mass also, M to the power B, and T is proportional to acceleration due to gravity G, G to the power C. Okay, so if I combine everything, all of you listen here, if I combine everything, so T is proportional to L to the power A, M to the power B, and G to the power C. So I am assuming that dimension, there is a constant which is dimensionless. So constant K, L to the power A, M to the power B, and G to the power C. So this is the equation I'm assuming. If I know what is A, B, and C, I have solved this question, right? But I need to find out what is the value of A, B, and C. K is dimensionless. Now try it. You can't find the value of constant by using dimension analysis. Okay, constant you can find by conducting some basic experiments. But relation you can't find by doing experiment. A is 1 liter. What is that? Okay, okay. No, or some mistake you did somewhere. Check. Okay, should I do it now? Should I do it? All of you, listen here. Listen. This one question I'll do it, then you'll be able to solve all the questions which are related. Okay. So dimensional equation, this is how you write it. Dimension of T will be equal to dimension of length to the power A, dimension of mass to the power B, and dimension of G to the power C. Right? Okay. Now you might have seen that earlier I used to write like this. Dimension of length is equal to m to the power 0 L1 T minus 1. The shorthand to write this is simply LT minus 1. You don't need to write M because it has power 0. Okay. So T dimension of T is dimension of L to the power A, dimension of M to the power B, and dimension of G to the power C. So this can be written as L to the power A, M to the power B. Dimension of G is what? Everyone. Dimension of G. What it is? G is acceleration due to gravity, isn't it? G is acceleration due to gravity, which is acceleration only. That is length time minus 2 to the power C. All right. So if I rearrange everything, I'll get M to the power B, L to the power A plus C, and T to the power minus 2C. Anyone has any doubt till now? Anyone has any doubt? Please type in. Anyone has any doubt? This is very important numerical. This you must understand. And this is from your NCERT book only. Exercise example number 2.17. All of you understood? Please type in. Okay, now what to do? Now tell me dimension. What is the value of B? Everyone, B is what? B. If I compare left hand side and right hand side, B is 0. So I can say B is equal to 0. Okay, then minus 2C is what? Coefficient of T is 1. So minus 2C is 1. So C is equal to minus half. And if C is minus half, I know A plus C should be 0. So A is equal to minus C, which is half. So B is 0, C is minus half, and A is half. So this problem is correct. So this problem is solved, we'll be getting t is equal to some constant times L to the power half, M to the power 0, B is 0, and G to the power minus half. So you will get t is equal to some constant root over L by G. So you can see here, even if you don't know the formula, what it is, all you have to know on what parameters it depends on, and you'll get the answer, you'll get the formula itself. So you using dimensional analysis, many problems can be solved. So you have got the expression here, but yes, constant k you can't find using dimensional analysis because it is dimensionless. In dimensional equation, k will not feature. So that value of k you can find experimentally. You draw a graph between t and root over L by g. The slope of the graph will be k. Okay, Ansh is asking, how does it depend on m then? See, Ansh, it is, it is like this. You have conducted experiment. You think that it depends on mass also. So just to play safe, you are assuming it depends on mass. Fine. So finally it comes out that mass doesn't matter. Okay. Any other doubt? Anyone? All right. So guys, let's take up the questions which have been asked in few competitive exams. Let us see. Again, the level of questions from this chapter will be very simple and straightforward. Uh, that there will not be much of a difference between JEE level and school level. So this is such chapter. Do this. This is pressure P. This is pressure P. All of you done? Dimension of energy to you anyway know, right? mL2 T minus 2. Any form of energy should have this dimension. Time period dimension is T. What is the density of rho? Density's dimension is what? Everyone. Dimension of rho. Dimension of rho. Mass by volume. Mass by volume, right? Volume has a dimension of length cube. So mL to the power minus 3. Pressure has what dimension? Dimension of pressure. Pressure has a dimension of force divided by dimension of area. Dimension of force is what? Mass into acceleration, mLt minus 2 divided by area dimension is L square. So what is the dimension of pressure? What should I write here? M. Everyone, what should I write? M. Parvati, what should I write? Sanmukh. Arya. Arabi. Dimension of pressure, what should I write? No one? Yeah, what is dimension of force by area? What it is? M. L minus 1 T minus 2. This is the dimension to the power C. Correct. So if I rearrange the terms, I'll get M to the power B plus C, L to the power minus 3B minus C, and T to the power A minus 2C. This is what I will get. Okay. Fine. So I can say that B plus C is equal to 1. Fine. Minus 3B minus C is equal to 2, and A minus 2C is equal to minus 2. How many of you got these three equations? Did you get these three equations? Okay, great. So using these two equations, you'll get the value of B is equal to minus 3 by 2. This is B. So C will be 1 plus 3 by 2. So C will be 5 by 2. Okay. If C is 5 by 2, the value of A is minus 2 plus 5, that is 3. Fine. So this value, all you have to substitute values of A, B, and C. So 3 square into 5 by 2 divided by 5 into B square, which is minus 3 by 2 whole square. Okay. So getting the value is not important. I don't care about the final answer. What I care about is the process, how you get it, this answer. Okay. All of you understood? Please type in yes or no. This is how it will be there in JEE, and I'm sure you have understood that the level of JEE is similar to the level of school, at least in this chapter. Okay. All right. So we'll take few more questions. We have 20 more minutes. This one. You won't believe this actually came in J Advanced. You don't need to know anything about R. Dimension of B will be what? Dimension of you can see B is getting subtracted from V. So dimension of B should be equal to dimension of V, isn't it? So dimension of B should be equal to volume dimension is L cube. This one. So option A though is correct. What about dimension of A? All of you. Find out dimension of A. These are very simple questions. Very, very simple. Okay. These are laddus. Tirupati laddus. Dimension of pressure. Can I say it is dimension of A by V square? All of you? So dimension of A will be equal to what? Dimension of pressure into dimension of V square. Dimension of pressure. What it is? Dimension of pressure is dimension of force divided by dimension of area. This into dimension of V square. Alright. Dimension of force is mass into acceleration mlt minus 2. That divided by area is L square and V square is L to the power 6. Getting it? So this will come out to be L square will become minus 1. This will be M L to the power 5 T to the power minus 2. Okay. So A and what is the difference between this? Oh, this is A and C. Now, is option B also correct? Is option B also correct? Find out dimension of Joule meter cube. What it is? Joule is a dimension of energy and meter cube is L cube. Dimension of Joule meter cube is what? Find out. Dimension of Joule then meter cube is L cube. Meter cube is what? Sorry, Joule is what? Energy. Dimension of energy is mL2 T minus 2 into L cube. So you can see that even Joule meter cube also has the same dimension. Okay, so even B is correct. All right. So this is how you get tricked. If you're in a hurry, you will not check for B. Any doubts anyone has? All of you, please type in. Anyone has any doubts? No, it will be partial mark, Ansh. This is J advanced. So if you mark all option correct, you get 5. Okay. Listen here. If you mark all the correct options, you get plus 5. If you mark only 2 out of 3 correct, you get 2 marks. If you mark only 1 out of 3 correct, you get 1 mark. So partial correct is plus 1 for each correct one. If you mark all the correct, you get plus 5. But if you mark an incorrect also along with the correct, suppose you mark A, C and D, you'll get minus 2. Okay. So marking scheme is very strict in J advanced. So, and sometimes, yes, it depends on the marking scheme also. Every year marking scheme keeps on changing. For some year, before I think 2016, it was like you need to mark all the correct options. If you don't mark, you lose all the marks. You get minus 1. Stop talking. Hold on. So if you mark before 2016, the marking scheme was if you don't mark all the correct ones, you will get minus 1. Okay. After that, partial mark was introduced. All right. But nobody knows what will happen. So you must read the instructions. Every exam you write, you should spend some time reading the instructions. That is very, very important. Okay. Somebody was saying something. No one. All right. Do this. Should be simple. Momentum is mass into velocity. Momentum is mass into velocity. You can find out dimension of momentum. Everyone attempt this and tell me your answers. Okay, so correct answer is n equal to 2. So we'll see e to the power n is equal to p square c square plus m naught square into c to the power 4. Dimensional equation will be dimension of energy to the power n being equal to dimension of p square c square equal to the dimension of m square c to the power 4. So any two combinations you can take. I will take this and that. It will be straightforward. Dimension of energy is what? M L2 T minus 2 to the power n is equal to dimension of m square is m2, c to the power 4 is L4 t to the power minus 4. Okay, so if you can see here, this is m L2 t minus 2 the whole square. Okay. So the value of n is 2. Understood, all of you? Achha, now tell me any doubts from anywhere from the chapter, okay? Any doubts from anywhere from the chapter? We are done with this chapter, okay? Anyone has any doubt starting from the previous class till now, whatever doubt you have, please ask, okay? Don't leave it for later on that, okay, I'll check later on. Then that later will never come and you're anyways spending time here. Can you just explain this question again? See, this is an equation given to you, e to the power n is equal to p square c square plus m square c to the power 4. This is an equation. This equation should be dimensionally correct also because it's a valid equation. So dimension of e to the power n is equal to dimension of p square c square is equal to dimension of m naught square c to the power 4. These two dimensions should be equal because you're adding the variables. You can add the variables only when their dimensions are equal. Fine. So dimension of this is equal to dimension of that. Now dimension of that can be written as m naught square is m square, then 3 to the power 4 is the velocity dimension to the power 4, and then you take 2 common, and then you compare n should be equal to 2 for them to be equal. Understood, Oro? All right, in the scientific notation of scientific figures, do we need to find significant figure for SI unit or whichever unit is given? Whichever unit is given to you. If you change the unit, only 10 to the power will change. A will not change. Okay, A will remain A only. So if you write meter in mm, let's say if you write 2 into 10 to the power 2 meters in millimeters, so it will be 2 into 10 to the power 5 millimeters. Significant figure here is 1, here also 1 only. Changing units won't change these significant figures if you write in scientific notation. That is the best part about the scientific notation. Okay. Others, keep typing in your doubts. Everyone. What else? You want me to take your names? Okay. Arabi, what is your doubt? Arabi, is it clear? Do you have any doubts? Others, quick. No doubts? All right, so I will conclude in the next this thing slide. So guys, here is a thing. The chapter number 1 is over. Chapter is over. Okay, so if you think that you can let the syllabus get over and then you'll study on your own, you're dreaming. Okay, it doesn't happen like that in class 11th. The syllabus will get over few days before your final exam. Okay, so this is the time for you to complete the chapter your own, whatever you want to do. So we have just, my role was just to introduce you that these concepts exist, right? I cannot practice on your behalf. All right, so you will see that few students will be working hard as the class progresses. For example, I'm teaching this thing, the students will be solving problems on that chapter and they will be slightly moving ahead, and like that they'll keep on working hard, they'll keep on moving ahead like that. So there is the only difference, everybody else will attend the class. Fine. So there are around 20 lakh students who are preparing for competitive exams. So if you think that you can just attend the classes and that is all it is required, you're fooling yourself. So the bare minimum that you can do is this, the bare minimum. Bare minimum is to complete the assignment. To complete the assignment. And if you are completing it very fast by looking at the solution, again you are wasting your time and fooling yourself. So you need to struggle through the assignment, you need to fight it out, you need to discuss the doubts. Fine, like that you complete the assignment, and that is your bare minimum. That will ensure your ranks around 2 to 4 lakh. Okay, so don't be surprised if you think that ranks are in lakhs. 20 lakh kids are writing exams, somebody will get that rank. Okay, 2 to 4 lakh out of 20 lakh you will get when you do the bare minimum thing. If you think that you want to be in top 1 lakh kids, please start doing much more than what is required, bare minimum. Okay, so you need to practice a lot of questions yourself. Now is the time, you have no school pressure, nothing. So completing assignment is the most it is the minimum thing that you can do. All right, so make sure you don't falter on these things. Keep these things in mind, that everybody else is also working hard, everybody else is also attending classes. The only difference will be how much hard work you do when you are at home, not how many classes you attend. Fine. Yes, we have already shared all the books, right? On Google Drive, we have shared. When the lockdown gets over, we'll hand over the physical books also to you. Meanwhile, there is no dearth of material. If you think that you have lesser number of questions, ping me. I'll just give you all many questions. Okay, so don't worry about which book to follow, from where to solve. If you have that kind of problem, you just ping me. I'll send you many more questions. And yes, it is required. Okay, if you do bare minimum, you will get bare minimum result, which is around 2 to 4 lakh rank. If you don't know bare minimum, then somebody will be around 12 lakh, 15 lakh, right? Anyways, so I'm not scaring you, I'm just telling you the reality. Okay, so if somebody telling you no, it is all chilled out, you don't need to work hard, it is very, I'll tell you the shortcuts and tricks and this and that, that is the most stupidest thing you can do. Because if there are shortcuts, everybody will know. If there are tricks, everybody will know. And once everybody know, it no longer is a trick. Yes, you can start attempting the NCERT examples also, but NCERT examples we have anyway covered in the class itself. So I'll be sending you the assignments over the WhatsApp group. Once you are done with those assignments, please message in the group only that can you send more questions on this topic, sir, because I want to do them. Okay, once you start sending those kind of messages, then I'll also like to send those questions. Otherwise, I'll just send it, nobody will bother to check, and it will just lie there. All right, guys, so that's it from my side, and we will start kinematics from the next class. It will be pure physics. All right, so thanks for coming in. We will meet again next week. Till then, take care. Bye for now.